Trees. What is a tree? Tree is a non-linear data structure which organizes data in a hierarchical structure, and this is a recursive definition. Tree traversal. Today the topics which we are going to discuss are node, root, edge, parent, child, sibling, leaf, internal nodes, degree, level, height, depth, path and subtree. Node. In a tree data structure, every individual element is called as node. Node in tree data structure stores the actual data of that particular element and linked to next element in a hierarchical structure. Here in this below example, we can see we have 11 nodes. Root. In a tree data structure, the first node is called as root node. Every tree must have root node. We can say that root node is the origin of a tree data structure. In any tree, there must be only one root node. We never have multiple root nodes in a tree. In this below example, we can see A as a root node. Edge. In a tree data structure, the connecting link between any two nodes is called as edge. In a tree with n number of nodes, there will be maximum of n minus 1 number of edges. In below example, as we have 11 nodes, we will be having 10 edges. Parent. In a tree data structure, the node which is predecessor of any node is called as parent node. Parent node can also be defined as the node which has child or children. Here in this example, we can see A, B, E, C, G are the parent nodes. Child. In a tree data structure, the node which is descendant of any node is called as child node. In a tree, any parent node can have any number of child nodes. In a tree, all the nodes except root node are child nodes. Here, in this example, B and C are children of A, D, E, F are children of B, whereas K is children of G, and it goes so on. Siblings. In a tree data structure, the nodes which belong to same parent are called as siblings. Here, B and C are siblings as they belong to the same parent, which is A. Leaf. In a tree data structure, the node which does not have a child is called as leaf node. In a tree data structure, the leaf nodes are also called as external nodes. External nodes is also a node with no child. In a tree, leaf node is also called as terminal node. Here in this example, we can see D, F, I, J, K and H are leaf nodes as they do not have a child or children. Internal nodes. In a tree data structure, the node which have at least one child is called as internal node. In a tree data structure, nodes other than leaf nodes are called as internal nodes. The root node is also said to be an internal node if the tree has more than one node. Internal nodes are also called as non-terminal nodes. Here, A, B, C, E and G are internal nodes. Degree. In tree data structure, the total number of children of a node is called as degree of that node. The highest degree of a node among all the nodes in a tree is called as degree of a tree. Here, degree of B is 3, whereas degree of A is 2. Here, B is called as the degree of tree. Level. In a tree data structure, the root node is said to be at level 0 and the children of root node are at level 1. And the children of nodes which are at level 1 will be at level 2 and so on. The level count starts with 0 and incremented by 1 at every step. Here A is at level 0 whereas B, C are at level 1 and it goes so on. In a tree data structure, the total number of edges from leaf node to a particular node in the longest path is called as height of the node. In a tree, height of a root node is said to be the height of the tree. In a tree, height of all leaf nodes is 0. Here, height of A, which is root node, is 3, whereas height of B and C is 2. Depth. In a tree data structure, the total number of edges from root node to a particular node is called as depth of that node. In a tree, the total number of edges from the root node to a leaf node in the longest path is called as depth of the tree. In a tree, depth of the root node is always 0. Here, as A is the root node, its depth is 0. whereas the depth of I, j and k is 3. Path. In a tree data structure, the sequence of nodes and edges from one node to another node is called as path between that two nodes. Length of path is total number of nodes in that path. In below example, the path A, B, E, G has length of 4. This is the longest path. Subtree. In a tree data structure, every child from a node forms a subtree recursively. Every child node will form a subtree on its parent node. Here, the circular paths we can see are forming subtrees. Binary trees. In a normal tree, every node can have any number of children. Binary tree is a special type of data structure in which every node can have maximum of 2 children. One is known as left child and the other is known as right child. In simple words, we can say a tree in which every node can have maximum of 2 children is called as binary tree. In a binary tree, every node can have either 0 children or 1 child or 2 children, but not more than 2 children. In this example, we can see every node has either 0 children or 2 children. Binary tree traversals. Displaying or visiting orders of nodes in a binary tree is called as binary tree traversal. There are 3 types of binary tree traversals: in-order traversal, pre-order traversal, post-order traversal. In-order traversal. In in-order traversal, the root node is visited between the left child and the right child. In this traversal, the left child node is visited first, then the root node is visited, and later we go for visiting right child. This in-order traversal is applicable for every node of all subtrees in the tree. This is performed recursively for all nodes in the tree. In this below example, it first goes to A, but as A is the root node, it goes for its left child as per the condition. Here again, A is the root node of D and E, so it checks for its left child, which is D. Then again, D checks for its left child, which is I. As it does not have any left child, it visits I and it goes for the root node of I, which is D. And then the right child of D is J, so it visits J, and this process occurs recursively and it continues further. The final order which we will get is it visits first I, D, J, B, F, A, G, K, C and finally H. Pre-order traversal. In pre-order traversal, the root node is visited before left child and right child nodes. In this traversal, the root node is visited first, then its left child and later its right child. This pre-order traversal is applicable for every node of all subtrees in the tree. Here, it first goes for A. As per the condition, it should visit root node first. So, as A is the root node, it goes and visits A first, then followed by its left child, which is B. Then it visits B and then it checks for its left child. Here, as D is also a root node, it visits D and then it checks for whether it has a left child. Then as I is the left child of D, it goes and visits I. Then it checks for its right child, which is J, and this process continues and will get the order as A, B, D, I, J, F, C, G, K and finally H. Post-order traversal. In post-order traversal, the root node is visited after left child and right child. In this traversal, left child node is visited first, then its right child and then its root node. This is recursively performed until the rightmost node is visited. Here in this below example, we can have the order as I, J, D, F, B, K, G, H, C and finally A.